Hello everyone and welcome back to the AWS Solution Architect Associate series. Today we continue the domain 3, that is design high performing architectures, and our focus is on determining high performing data ingestion and transforming solutions. Modern architectures rely heavily on the efficient data ingestion and fast processing and also the scalable transformations, especially for the analytics, streaming, IoT, machine learning pipelines, and also the event driven applications. In this video, we will explore the ingestion patterns, streaming architectures, data transfer services, transformation tools, data lakes, analytics services, and the compute options that support high performance data processing at scale. Let's get started. The first step in designing high performing ingestion pipelines is understanding the ingestion requirements. Every workload differs in how frequently data arrives. Some use batch ingestion at scheduled intervals, and while others use real-time streaming to process continuous events. You must also evaluate the size and velocity of incoming data to determine the right ingestion tool. For example, high volume logs or sensor data requires a streaming service, while nightly extract transform load jobs may only need batch ingestion. Security is equally important. Ingestion endpoints must be protected using IAM, VPC endpoints, private access, and then signed requests. By clarifying these requirements early, you ensure the architecture supports the right performance, reliability, and security from the start. Batch ingestion is commonly used when data doesn't need to be processed in real time. Organizations frequently upload files to Amazon S3, especially the CSV, JSON, Parquet, or the log files, where they serve as input for analytics and ETL jobs. Services like AWS DataSync automate the high-speed transfers between on-premise storage and AWS, while the AWS Transfer Family enables the file-based ingestion using SFTP, FTPS, and FTP. Batch ingestion is highly cost efficient and scale seamlessly when built on S3. It's ideal for data warehousing, nightly reporting, archival ingestion, and pre-scheduled transformation. For real-time use cases such as clickstream analytics, IoT telemetry, financial transactions, or the live application logs, AWS offers Kinesis ecosystem. Kinesis data streams captures the high velocity data in real time and allows the applications to process it within milliseconds. Kinesis Firehose provides a fully managed path to load streaming data directly into S3. Redshift, OpenSearch, or the third-party endpoints without managing the infrastructure. Streaming architectures enable the continuous processing, low latency analytics, and near real-time monitoring, making the Kinesis a core component of high-performing ingestion solutions. When building a scalable data lake on AWS, Lake Formation simplifies the ingestion, management, and governance. It helps centralize all the structured and unstructured data inside S3 while also managing the security and access controls. Lake Formation provides fine-grained column-level permissions, automated metadata cataloging, and integration with Glue, and also with Athena, Redshift, Spectrum, and EMR. This ensures that no matter how data enters the lake, batch or the streaming, it remains secure, discoverable, and governed properly. A well-structured data lake is essential for high-performance analytics at enterprise scale. AWS Glue is the primary service for scalable data transformation. It provides serverless ETL jobs that automatically scale resources to process large datasets. Glue crawlers can detect the schema and populate the data catalog, making datasets query ready. Glue also excels in converting data formats, for example, transforming CSV files into the optimized Parquet or the ORC formats, which dramatically improves the performance for analytics queries. For no-code transformations, Glue Data Brew lets users clean and prepare the data visually. Glue plays a central role in in preparing the data for analytics platforms such as Athena, EMR, Redshift, and data lake pipelines. To derive insights from the ingested data, AWS provides powerful analytics tools like Amazon Athena, which is a serverless interactive query service that allows you to run SQL queries directly on S3 without provisioning the infrastructure. It's ideal for data lake analytics, also for log analysis and the ad hoc querying. For dashboards like BI use cases, Amazon QuickSight provides a fast, scalable data visualization with built-in ML insights. Together, these services deliver end-to-end analytics capabilities from ingestion to transformation to visualization with minimal operational overhead. Choosing the correct compute service for data processing is critical. Amazon EMR is ideal for large-scale distributed workloads such as Spark, Hadoop, Hive, and Presto. It gives you fine-grained control, excellent performance tuning, and also the cost flexibility through spot instances. For event-driven pipelines, AWS Lambda can process the objects as they arrive in S3 or handle streaming events from Kinesis. And Glue ETL jobs provide the serverless batch transformation at scale. Matching the compute engine to the workload ensures the maximum throughput, optimal cost, and predictable performance. Security must be built into ingestion pipelines from the beginning. VPC endpoints ensures that the traffic ingestion stays inside the AWS network. IAM rules and fine-grained policies ensures only authorized applications can write data into the ingestion points like S3 or the Kinesis. Encryption, whether it's a transit or in at rest, protects the sensitive information while checksum validation ensures the data integrity. These security practices ensures your ingestion pipelines remains compliant, tamper resistant, and resilient. Choosing the right ingestion strategies involves balancing the performance, cost, and complexity. Batch ingestion is ideal for predictable workloads, while streaming is the best choice for low latency or high velocity scenarios. You must also select the right storage formats. For example, columnar formats like for Parquet significantly improves the query performance and reduce the cost for analytics workflows. Building a lifecycle aware pipeline that support the transition, transformation, and archival ensures your ingestion architecture remains both the high performance and the cost optimized. A high-performing ingestion and transformation architecture brings together the multiple AWS services in a cohesive flow. Data may enter through batch uploads, file transfers, or the real-time streams. It lands in S3 or Kinesis, gets transformed by Glue or EMR, and then becomes query ready for Athena, Redshift, or the QuickSight. The key is to choose the right components, serverless where possible, scalable where needed, and secure at every step. By combining batch and streaming patterns, organization can build pipelines that can handle every workload efficiently and reliably. So to summarize, in this session we explored how to design the high-performing data ingestion and transformation solutions using AWS services. We studied batch and streaming ingestion, Kinesis data lakes, Glue transformation, analytics with Athena and QuickSight, and also how to choose the right compute engine for scalable data processing. These skills are essential for building modern, high-performing architectures that support analytics, machine learning, and real-time data processing. In the next video, we begin Domain 4, which is design cost-optimized architectures, and we'll start with designing cost-optimized storage solutions. Make sure to like, subscribe, and follow along as you continue the series. See you in the next session. Thank you.